So the whole purpose behind the next few podcasts is review. And if you look at this, we have weapons of math destruction. We have our graphing method to find roots. We have our factoring method to find roots. We have our completing the square method. And last but not least, what the last 10 podcasts have been on is this wonderful thing we call the quadratic formula. So you at this particular point, folks, are very, very powerful mathematicians. But the question is, when do you use each one of these? Well, when solving a quadratic, the variety of methods are available to use. Which one you use depends entirely on the type of question you're given. Case in point, look at this next question right here. I'm going to tell you straight out to use your calculator on this, and you're going to see why in a second. Think about this. This is a PSA 2, which means you have to multiply these guys together to give you 27. Then you want numbers that multiply to give you 27, and too much of a hassle. So in this particular case, you can always use your calculator to verify the answers. But in this particular case, I want to be able to use this graphing calculator right here, and I want to solve this. I want to get kind of friendly with using my calculator again. So clear this stuff out of here. Here we go. 3x squared plus 28x plus 9. So what is the system of doing this? First thing is enter in your calculator. Graph it. That would be number 2. Boom, boom. You might have to adjust the windows. You'll notice that this does not show you the vertex. But do you really care about the vertex? No. You care about this point and this point, and whatever those 2 points just happen to be. Easiest way to do this? Simple, simple, simple. Second calc. Find the 0, 2. And whatever you're close to, look at this. Find me the left bound. Here we go. There's the left bound. Hit enter. Find me the right bound. Hit enter. And of course, guess. Our first one is negative 0.33333. Now, I know what you're thinking. How do I put that into my calculator so I can actually determine a fraction? Simple. Watch this. Hit clear 3 times. Brings this up. You might even want to hit clear 1 more time. Then hit X and hit equals to. Boom. There it is, negative 0.3333. There's the value that you actually had on your calculator. Put that into fractional form, math frac, there it is, and you get negative 1/3. So your first answer here is negative 1/3. That's your first root, okay? So find the second root. Well, go back to the graph, there it is, okay? You want to find the far left one. Second calc, find me the far left 0. Okay, here we go. Doon, doon, doon. Now notice, it disappears for a while. Because if you think about it, you're at negative 1.666, which is still right around here somewhere. It's right around here. So you're way down on the graph, somewhere way down over here. You don't know where it is. Well, keep on mousing until you get this number close to your value. And if you look at this value, it's 1, 2, 3, 4, 5, 6, 7, 8, 9. You want to value this to be somewhere around negative 9. Okay, so keep your eye on that thing that says left bound. Let's go. Da, 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 da. And it takes you a while to get there. And suddenly, right away, we're getting close. There's 5, there's 6, 7, 8, and there it is. Oh, it just passed us. Whoa, there it is. There's our left bound at negative 9.2. Hit enter. Get my right bound, so you got to be below it. There it is. Hit enter, and of course, guess, and you get a value of negative 9. So your x values, your x intercepts, or your solutions are negative 9 and negative 1/3. What a great way of doing this. And then, of course, you can work backwards and figure out what this guy looks like in its nice, beautiful factored form. So x equals to minus 9. Add 9 to both sides. That's x plus 9. This guy, of course, would be x equals to minus 1/3. Multiply by 3 both sides. You got 3x equals to minus 1. Bring that over. You got 3x plus 1 equals to 0. There's your 2 factors, and that's the factored form of this guy right here. Really pretty, real easy way of figuring out not only the zeros, but what the original factors were.